So in this video, I will teach you how to name reactions through their mechanism. So bago tayo mag-proceed sa ganung task, we'll just recall some concepts. So ang unang concept ay yung nucleophilic. So pag tinawag kang nucleophilic, or if the substrate or the reagent is nucleophilic, ibig sabihin sila ay electron pair donors. They are usually the ones with a high electron density. Sila yung maraming idodonate na electron, kaya sila yung nagdodonate. Okay? Electrophilic naman kapag electron pair acceptors. So kapag acceptor, okay, sila yung tumatanggap ng electron pair kasi sila yung kulang naman sa electron. Okay? So na-review na natin to through the molecular orbital theory. Makikita natin doon na minsan may mga compounds na nucleophilic and may electrophilic based doon sa kanilang HOMO and LUMO. Pero dito sa part na to, hindi natin kailangan kunin yung mga molecular orbital nila. Makikita mo lang yon sa kanilang reactivity or sa kanilang usual reactivity pagdating sa mga reactions. Okay? Also, we'll study the kinetics of the reaction. Okay? So, i-define natin na kapag unimolecular ang isang reaction, this particular reaction is a first order reaction. So, yung mechanism niya, first order. Ano ibig sabihin nun? Sa unang step ng reaction, okay, yung substrate lang yung involved. Hindi involved yung reagent. Okay? Siya lang yung nagbabago sa unang step. Hindi siya tulad ng bimolecular na parehong nagpa-participate yung substrate tsaka reagent sa reaction sa first step. Or at least the slowest step ng reaction. So kapag ka bimolecular, 1 mole ng substrate and 1 mole ng reagent yung nagpa-participate sa unang step ng reaction. Okay? Usually sa organic chemistry, yung first step yung pinakamabagal because of the transformation to the intermediate. Okay? So, kailangan natin i-consider yung kung sino yung nagpa-participate. Kapag unimolecular, yung substrate lang yung nakikita nung nag-change. Kapag bimolecular, parehong involved yung substrate and reagent. Okay? So, paano natin ngayon i-name yung mga reaction? So, meron tayong general rule. So, in naming, okay? So, in naming a certain reaction, ang pangalan niya halimbawa ay nucleophilic, okay, addition. Okay? So kapag nucleophilic addition, wala naman siyang regard sa kinetics, okay? So laging iisa lang ang passion ng kanyang reaction. So hindi mo kailangang i-classify kung unimolecular or bimolecular siya. Lagi siyang bimolecular. Okay? So hindi siya usually dinidefine like that. So dito, yung reactivity ng reagent yung unang term. So, ano ba yung reagent mo? Reagent, ha? Hindi yung substrate. So, kung ang reagent nyo ay nucleophilic, ang una nyo ilalagay ay nucleophilic. Pagka electrophilic si reagent, electrophilic. Tapos, i-consider nyo yung reaction type. Ano ba nangyari doon? Okay, nagkaroon ba ng addition, elimination, substitution? Okay, so sa rearrangement, wala naman tayong involved na reagent doon, usually. So, sa reaction type, ilalagay mo kung addition, elimination, substitution. Okay? Then, usually, nilalagay natin yung reaction kinetics. So, ano yung reaction kinetics? Ilalagay mo usually kung unimolecular siya or bimolecular. So, ang pinaka-fit na example dito ay nucleophilic, substitution, okay, unimolecular. So, ang ibig sabihin, kung this reaction exists, it's a nucleophilic reaction kasi yung reagent mo dyan ay yung nucleophile. Okay? And then, the substitution, okay, kasi the nucleophile substitutes something that is already in your substrate. So, yung reagent mo, siya yung magsa-substitute doon sa nakalagay na sa substrate. So, matatanggal yung nasa substrate na yan kung ano man yun. Unimolecular, ibig sabihin, first order yung reaction. Okay? Usually, ginagawa nila to ng mga symbol. So, sa particular example ko na nucleophilic substitution unimolecular, ang kanilang symbol for this is S for the substitution, nucleophilic, unimolecular. So, yan yung SN1. So, kapag ka bimolecular nucleophilic substitution, SN2. Okay? Kasi yung mga nucleophilic substitution, they can be either unimolecular or bimolecular. So, usually ni-specify natin kung ano yung klase ng reaction. Okay? So, ngayon, that's our standard naming. So, mag-name na tayo ng mga reactions. So, try natin yung una. So, the first one actually is an addition reaction. So, alam mo na, an addition siya kasi nag-add yung HBr dun sa alkene. So, nagkaroon ka ng alkyl halide. However, what is the first step of this reaction? So, sa part na to, i-declare ko lang muna yung mechanism. Kasi hindi pa tayo nag-aaral ng mga functional groups. So, yung mga reactivity ng mga functional groups na yon is to be discussed pa. Okay? So, the first step of this reaction is usually like this. Okay? So, umatak yung pi bond or yung electron pair from the pi bond of the cyclohexene. So, ibig sabihin, is HBr a nucleophile or an electrophile? Okay? Since siya yung nagtanggap ng electron pair from the substrate, siya yung electrophile. So, the reagent is electrophile. Okay? So, this reaction is actually an electrophilic addition. Hindi ko na isusulat yung kabuuan ng mechanism na to. Okay? So, this reaction is an electrophilic addition. So, ilalagay ko lang siya sa tapat. Okay? Lagay ko dito. Electrophilic addition. Okay, sige. Isusulat ko na yung buong mechanism. So, kapag tumanggap siya ng electron pair dito, syempre hindi po pwede magkaroon ng dalawang electron pair yung hydrogen kasi isang electron pair lang yung capacity niya. So, ililipat niya yung electron pair sa bromine. So, bromine makes sense kasi siya ay octet. Okay? And bromine is usually electronegative. So, nakukuha niya yung electron pair. So, the first step is usually an equilibrium kasi this is an intermediate. So, this is a heterolytic bond cleavage. So, yung nag-bond na electron pair dun sa hydrogen, yun yung ones na pi bond niya. So, yung naiwan na carbon, makukulangan siya ng electron. So, that's an intermediate. Okay? Dito na ngayon a-action itong si bromine or si bromide. Okay? Aatakihin na niya ngayon si carbocation. Kaya magkakaroon tayo ng bromocyclohexane. So, this emphasis of the H is for mechanistic purposes. You don't usually expose or show the hydrogen unless kailangan mo siyang i-emphasize. Okay? So, this is the mechanism of this reaction. Okay? So, buburahin ko lang yung nasa side. Yeah. So, that is an addition reaction. So, that's an electrophilic addition. So, we don't need to specify the mechanism kapag ka-addition. Pero, pansin nyo naman, sa first step, this is a bimolecular reaction kasi involved yung substrate tsaka reagent. So, ang complete nito talaga ay electrophilic addition bimolecular. Pero we don't put the bimolecular because all electrophilic additions of this type are bimolecular. No need to classify, kumbaga. Okay? Number 2. So, the mechanism for number 2, okay, is this. Yung ethyl group or yung ethoxy group, since this is an ethanol, okay, ethanol yan. Pag tinanggal mo yung H, the conjugate base of this is ethoxy. Okay? Ethoxy. So, this is an ethoxide, actually. Okay? Ethoxide. Yeah. So, atak siya doon. And, syempre, hindi po pwedeng more than 4 bonds si carbon. Yung isang electron pair, i-donate niya doon sa oxygen. Okay? So, the intermediate is the actual product of the example. Okay? So, ano naging action dito ni reagent? So, si reagent ay nucleophile. Okay? So, therefore, this reaction is a nucleophilic addition. Okay? Again, this addition reaction involves both the reagent and the substrate. So, bimolecular siya. Okay? So, number 3. So, sa number 3, meron tayong dalawang ways para i-represent yung mechanism niya. So, the first one is a unimolecular fashion. So, unimolecular. So, anong meron kapag unimolecular? Pwedeng ang mangyari, okay, mag-change muna si bromocyclohexane. Magiging ano siya, carbocation. Okay? So, sa first step, substrate lang ang involved. Then, may involve dito si water. Siya ay nucleophilic kasi may mga idodonate siyang electron pair. Okay? So, it will involve actually another intermediate. Since dinonate ni oxygen yung isang electron pair niya, magkakaroon siya ng positive charge. Okay? So, hindi niya ibabalik yung positive charge na pag ganyan. Hindi na yun usually nangyayari kasi the oxygen-carbon bond is stronger. So, anong kukunin niyang bond para bumalik siya sa neutral? Yung sa hydrogen. Okay? So, this is what happens. Magkakaroon ka ng OH. Okay? And then, the Br minus, kasi based dun sa reaction natin, kukunin niya si hydrogen. Okay? So, the Br minus came from here. Siya yung, na-release ng reaction, kumbaga. Okay? So, ano ngayon ang naging action ni reagent? So, ang action ni reagent dito ay nucleophilic. Okay? And the reaction is substitution. So, therefore, this particular reaction is a nucleophilic substitution unimolecular. Okay? So, the unimolecular fashion, yun yung aking example. So, ang kanyang code or ang kanyang symbol or acronym is SN1. Okay? So, paano naman yung bimolecular na fashion? Okay? So, sa bimolecular, dapat involved na agad si substrate or si reagent sa simula pa lang. So, kapag involved na agad si reagent sa simula pa lang, okay, plus OH, okay. So, kapag involved na siya agad, mag-act na siya agad as nucleophile. At dito siya tatama kasi that's the carbon that is most nucleophilic kasi nakakabit siya sa halogen. So, halogens, they have this strong electronegativity. So, napupush yung electron density papunta sa kanila. So, ibig sabihin, this particular carbon in the cyclohexane has the least electron density. Okay? So, ganyan na mangyayari. So, syempre, yung carbon na yan, hindi niya masusustain yung 5 bonds. So, kunin niya or i-release niya si bromine. Okay? So, ang mangyayari, meron ka na agad nung intermediate na ito. Of course, nag-donate siya ng electron pair, so positive na siya agad. Na-release na agad si Br minus, okay, dito. And then, okay, ang gagawin niya, tulad ng ginawa dun sa unimolecular fashion, kunin si hydrogen, and hydrogen will donate its electron pair dun sa oxygen. So, same lang yung product ng reaction. Okay, so this is the same nucleophilic because water served as a nucleophile. So, yung water yung reagent dito and nucleophilic si water. Substitution. Okay. Bimolecular. So, that is an SN2. So, pwede ako magpakita ng mga mechanisms. Okay. And through those mechanisms, maniname nyo na yung mga reactions. Okay. So, this is how they actually name reactions in organic chemistry. So, very systematic, di ba? Ito naman ay elimination. So, elimination reactions also have 2 fashions or 2 particular mechanisms, unimolecular. Okay? So, sa unimolecular mechanism, substrate muna. Okay? So, kapag substrate muna, siya lang ang involved, aalis lang muna si bromine. So, magkakaroon ka ng carbocation. This is H. However, what's more interesting about this reaction is that yung OH minus mo dito, hindi siya nagre-react as nucleophile. Kasi kung nucleophile si OH minus, pupunta siya dun sa carbon center. No. OH minus in this situation acts as a base. So, ano ang definition natin ng base? Okay? H plus acceptor. So, saan kaya siya kukuha ng H dyan? Okay? So, dito siya kukuha ng H. And the bond here will be donated here para mawala yung positive charge. Okay? So, ulit. Kukunin ni OH yung hydrogen. Yung bond sa hydrogen at carbon ay mapupunta dito. Okay? So, magkakaroon ka ng alkene. So, basically, nagkaroon ka ng elimination reaction. Okay? So, plus water plus Br minus. Okay? So, that's the unimolecular fashion. How about the bimolecular? So, pag bimolecular naman, sabay-sabay na nangyayari. Okay? Involved na agad si base. Okay? So, pag involved na agad si base, bases will accept hydrogen. Okay? And the hydrogen-carbon bond will be converted to a pi bond. And then the bromine here will be released. So, ang mangyayari, kakaroon ka agad ng alkene plus Br minus plus H2. So, hindi natin dito i-mention si base kasi hindi naman siya tinatawag na elimination base. Ganun, something. Okay? This is just elimination unimolecular. Okay? Or the E1 mechanism. Dito naman, since this is a bimolecular, elimination bimolecular. Or E2. So that's it. Okay? So that's how you name the generic types of the reaction. There are other reactions that are actually named after their discoverer. There are other reactions that are too complicated for this system. Pero yung mga general types ng reaction, usually ganito sila pinapresent. Okay? Naka-base dun sa mechanism nila, yung name nila. Okay? So, see you next video. I-discuss ko pa to in further detail along with the structure and reactivity considerations sa organic compounds.